Hello my friend, happy to see you here. Today we have a great algebra question. We have 2 to the a plus 4 to the a equal to 8 to the power a. Great, quick and relaxing algebra question. Right now you can easily pause the video and try to solve this question on your own, and then we will check your answer, so it will be really interesting. So right now let's start. First of all, 2, 4 and 8 are great numbers because, for example, 4 we can write as 2 square, 8 we can write as 2 cubed, so then we will have the same base. So let's start with this moment. So we have 2 to the a, we have 2 to the a, and instead of 4 we write 2 square. So 2 square to the power a equal to, instead of 8 we write 2 cube. So 2 cube to the power a. And right now we need to learn a really interesting property, maybe the most popular property, when we have a to the power x raised to the power y. So when we raise this with parentheses, we can write it as a to the power x times y, a to the power x times y. So we can multiply our power. So I'm going to start it on the left side. So we have 2 to the a plus 2 to the power 2a, 2 to the power 2a, and equal to 2 to the power 3a, yeah? 2 to the power 3a. Really great. So what we're going to do next, every time we have this type of equation, so we have something on the left side, on the right side, my quick recommendation, just write everything on the left side. So that's why we write 2 to the a plus 2 to the power 2a and minus this 2 to the power 3a and equal to 0. Okay, so I hope you understand this step. What we're going to do next, right now let's factor 2 to the a. We can easily factor one of these 2 to the power a. So let's do it. So we have 2 to the power a, and in parentheses from here we have 1 plus 2 to the power a, 2 to the power a, and minus 2 to the power 2a, because we take away this one. So we have 2 to the power 2a equal to 0. Right now, what we're going to do next, I recommend you to write the substitution. So let 2 to the power a equal to t. So 2 to the power a equal to t. And we have restrictions right here, because if 2 to the a equal to t, then t is not equal to 0. T is not equal to 0. And second one, t is greater than 0. T is greater than 0. Okay, so right now let's use this substitution. As a result, what do we have? T. And in parentheses we have 1 plus t and minus t square. 1 plus t and minus t square. And a lot of students might be asking why right here we have t square, because we can write this one as 2 to the power a square. So maybe you don't understand why I write this as t square. So this one we can write, so let me just put right here this sign. Okay, right here we can write this as 2 to the power a square, according to the same logic. Okay, this one is 2 to the power a square, and of course equal to 0. Right now, a product of two parentheses equal to 0 when the first parenthesis, or not like parentheses, we have two expressions, this expression and parentheses. Okay, so a product of two things equal to 0 when the first thing equal to 0, so t equal to 0, or the second parenthesis equal to 0. So we have 1 plus t and minus t square equal to 0. Okay, right now t equal to 0, but just look closely right here. T cannot be equal to 0, because then we will have 2 to the a equal to 0, so exponential function doesn't intersect with this linear function t equal to 0. So as a result, we can easily reject. So t equal to 0, we reject this branch, reject this. Maybe right here we have complex roots, but in our case we solving for real number roots. Okay, so our last hope is this quadratic equation. First of all, we can change an order real quick. We can write minus t square on the first position, plus t, and plus 1 equal to 0. And right now I really like this trick, this quick hint for everyone, because we don't like this negative sign in the beginning. So that's why my quick recommendation, just divide or multiply both sides, or you don't need to write it, just do it in your head. Oh, sorry. Just do it in your head, yeah. And right now let's multiply both sides by minus 1. So as a result we have t square. So we just change all the signs to the opposite one. T square minus t and minus 1 equal to 0. So we have a basic quadratic equation. So what we're going to do next, right now let's write all these coefficients and let's solve this quadratic equation. So I'm going to do it on the right side. So a equal to the first coefficient equal to 1, the second coefficient b equal to -1, and coefficient c equal to -1 as well. So right now let's solve it for discriminant. Yeah, let's do it. So d equal to b square minus 4ac equal to b square, so -1 square minus 4 times a times 1 and times c times -1. So let's evaluate it, let's simplify it. So -1 square equal to 1. This negative and this we have plus, so plus 4 times 1 times 1 equal to 4. So as a result we have 5. So our discriminant is positive. This is also really great because right here at this branch we will have two real number roots, number roots. It's also really great. So right now let's solve it for example, imagine this is our t first, so let's write that t first equal to 0. Of course we reject it. Maybe right here we have complex roots, so doesn't matter. So right here at this place I'm going to write t second and t third. Okay, this is also maybe a complex part right here, so t first, but in this case I'm going to write t second and t third because this is also a root but a complex one. Okay, t second and t third equal to, so minus b, all known formula, plus minus square root of discriminant and all over 2a equal to, so minus b minus -1 plus minus square root of discriminant square root of 5 over 2, and as a result our root we have 1 plus minus square root of 5 over 2. Right now, a few thoughts about this t second and t third, because just remember that t is not equal to 0 and t is greater than 0. Of course, we also rejected one of these, so we reject this t equal to 0, but t is also need to be positive. And right here, I feel that one of this root will be negative. So let's check it. So as a result, we have t second. Let's go with the plus sign. 1 plus square root of 5 over 2. And t third equal to 1 minus square root of 5 over 2. And I really hope you understand that if we look closely at t third right here, so 1 minus, of course 2 is positive, obviously, yeah, and our denominator is positive. What about this numerator, 1 minus square root of 5? It's really easy to check it because square root of 4 equal to 2. So as a result, 1 minus 2 is negative. And even we have square root of 5 is greater than square root of 4, you know, and right here we have a negative value. So as a result, our t third is less than 0. So it means that we also reject this t third. Maybe right here we have complex roots, so this is up to you. If you want to practice your complex numbers, you can easily solve this branch, but in terms of real numbers we reject this one. So our last hope, this is t second, numerator is positive, denominator positive, so everything is great. So let's go back to our substitution. So let me just write this thing. So but we had a substitution, so 2 to the a equal to t, so but 2 to the a equal to t. So that's why our next step is to solve an equation 2 to the a equal to t, equal to this 1 plus square root of 5 over 2. So let's solve it. First of all, maybe we're applying log, maybe this is the best thing, maybe the only one thing, because we need to solve it for a, and the best way to do it is to apply log to both sides. Log 2 to the a equal to log 1 plus square root of 5, 1 plus square root of 5 over 2. Okay, so we have something like that. Right now, this a, according to this log property, will come down in the beginning. So we have a log 2 equal to, what can we do with this thing? First of all, I want to leave it like that without any changes. So 1 plus square root of 5 over 2. And the final step, this is a constant, this is also a constant. So if you want to solve it for a, you need to divide both sides by log 2. Yeah, we need to divide both sides by log 2. So we have our answer log, this one, 1 plus square root of 5 over 2, and we divide it by log 2. And a few thoughts about this expression, because we can easily simplify this in numerator. Yeah, we can easily do this because when we have a log of a fraction, we can write it as a subtraction or like difference of two logs. So as a result, our a equal to, so log of a fraction we can write as log this numerator minus log of the denominator. So log 1 plus square root of 5, yeah, so 1 plus square root of 5 minus log 2 minus log 2 over log 2. Or we can easily see this log 2, and right here we can easily see this log 2. So as a result, we can divide by this log 2. So this is the common thing. So we have a equal to, so log 1 plus square root of 5, 1 plus square root of 5 over log 2 minus log 2 over log 2, and right here we can easily cancel this log on the right side. So the answer to this question is a equal to log 1 plus square root of 5 over log 2 over log 2, and right here we have 1, so minus 1. Or if you're interested in approximately answer, x approximately equal, so I'm going to write it right here. So x approximately equal, if you plug in it in a calculator, 0.694. This is our approximately answer, and this is our real number root. So this is my solution to this question. I really hope you understand it. I really hope you learned something new, but definitely don't feel bad if you got this wrong. If you need help with any of these classes, I have a lot of questions on my YouTube channel, a lot of different challenges, so I hope you will enjoy it. So thank you for your time, have a great day, and see you in the next videos.